Alright everybody, welcome back. In this video we're going to look at the first two examples from the Introduction to Riemann Sums lesson. And the first example says we're to sketch the function and the 5 approximating rectangles for LRAM sub 5 of f of x, and then we're going to calculate the approximate area under the curve between the given x values. So first things first, I'm going to sketch the function. Now I'm going to let each block horizontally stand for 1/2 unit, and I'll let each block vertically stand for 1 unit, so that I get a little bit bigger of a sketch of my graph to work with. And I'm just going to go ahead and plot values of y for the various x values. At x equals 0, y is 1. At x equals 1, y is 2. At x equals 2, y is 5. And at x equals 3, y is 10. And so this is our sketch of the curve. And so we're finding the area underneath this curve between x equals 0 and x equals 3. Alright, and we're going to do that using 5 rectangles. And we're going to get the heights of the rectangles, see right here 5. We're going to get the heights of the rectangles from the left endpoint of the interval that we're using. That's going to determine the value of the function that we use for the height of the rectangle. So the first thing I need to do is figure out how wide each of these rectangles are. The entire interval here is 3 units wide, and we're dividing that into 5 rectangles. So each rectangle should be 3/5 or 0.6 units wide. So I'm just going to make some marks down here at 0.6, because we'll have the interval from 0 to 0.6, and then we'll have the interval from 0.6 to 1.2, and we'll have the interval from 1.2 to 1.8, and the interval from 1.8 to 2.4, and the interval from 2.4 to 3. Those are going to be our 5 rectangles. And now I'm going to sketch in the rectangles. And let's see, let's use this lime green color. Now the height of the rectangle is going to be based off of the left endpoint of the interval. And so the height of this rectangle was determined by the value of the function over here at the left endpoint. And I'm going to sketch the rest of the rectangles in the same fashion. We'll put a rectangle in here. I got a little too low on that one. And a rectangle in here. You'll notice I'm getting the heights of each of these rectangles by going up to the curve at that left endpoint of the interval. And I'm missing my left endpoint a little bit. It's a little bit hard for me to control these rectangles. There definitely should not be spaces in between these last two rectangles. But you'll notice here that for this particular function, the LRAM value is going to be an under approximation for us. But what we need to do now is we need to calculate the area of each of these rectangles. The width of every rectangle is 0.6 units. And the height is going to be the function value at the left endpoint of each of these. So to calculate this area, or approximate this area, we're going to use the width of the rectangle times the height for the first rectangle. And the height is going to be the value of y at x equals 0. And we'll do the same thing. We'll take the width times the height at the left endpoint for the second rectangle, and the width of the rectangle times the height at the left endpoint for the third rectangle, which happens at 1.2, and the width of the rectangle times the height for the fourth rectangle, which is the value of the function at 1.8, and the width of the rectangle times the height for the fifth rectangle, which is determined by the value of the function at 2.4. And so since all of these have this uniform width, I'm just going to go ahead and factor that width out instead of doing all this different calculation. And then I'm going to find the height by substituting all of these x values into the original function to determine the height of the rectangle. So for the first rectangle, I put 0 in there. 0 squared plus 1 is 1. For the next rectangle, I put 0.6 in there. 0.6 squared plus 1 is 1.36. I put 1.2 in there. 1.2 squared plus 1 is 2.44. Then I put 1.8 into the function. 1.8 squared plus 1 is 4.24. And I put 2.4 in there. 2.4 squared plus 1 is 6.76. And now I'm just going to add all these heights together and multiply the result by 0.6. So 1 plus 1.36, it's 2.36 plus 2.44, that's 4.8, 9.04, 15.8 we get when we add all of those together. And when we multiply that by 0.6, we get our approximation of 9.48 for this area. Okay? And we know that this approximation is an under-approximation because we can see in this picture all of this unaccounted for space by these rectangles. Alright? Let's go down and we'll look at example 2 where we're using the same curve, only now we're using RRAM instead of LRAM. So I plot my same curve. Only now, instead of getting the heights of the rectangles from the left endpoints, I'm going to get them from the right endpoints. I still have the same width for each of these rectangles because we're still subdividing the same width interval. And now, for my rectangles, let's use orange instead. Alright, and the heights are going to be based off of the right endpoints. So a little bit bigger of a rectangle, because now these rectangles are going up to the right endpoint. And till I'm done making all these rectangles, you'll see that in this case, for this curve, RRAM is going to over-approximate the area. And I approach it the same way. I take the width of the rectangle times the value of the function now at the right endpoints. So for the first rectangle, I take it at 0.6. So I want the y value at 0.6. For the second, I want the y value at 1.2. For the third, I want the y value at 1.8. For the fourth, at 2.4. And for the fifth, at 3. And then I'm going to find all of those y values. Y of 0.6 is 1.36, and y of 1.2 is 2.44, and y of 1.8 is 4.24, and y of 2.4 is 6.76, and y of 3 is 9. And then I'll add all of those values together. Gives me 4.8, 9.04, 15.8, 24.8, and then I multiply 0.6 times 24.8, and I get 14.88 for my RRAM approximation of the area underneath this curve. And now we know that's an over-approximation. So we know that the true area underneath this curve is somewhere in between 9.48, which was an under approximation, and 14.88, which was an over approximation. Alright, that's where we're going to end the video for today. We'll come back in the next video and look at examples 3 and 4 from this lesson. See you guys then. Have a great rest of your day.